Happy Friday, everyone, and welcome to GeoHug. So I'm Jess from Prospectors and CoreSafe, and I'm your virtual host today. So this week's rockstar is Marina Costelloe from Geoscience Australia. So she's the acting branch head for the Mineral Systems branch for Geoscience Australia, and she's currently leading the minerals component of the $125 million 4-year expansion and extension of Geoscience Australia's Exploring for the Future program. So I'm so pleased that she's joining us today. She'll be sharing some highlights and future plans with us. Thank you so much again, Marina, for joining us, and it's so great to have you on today.
Thank you all for your time today. I'm so excited to share the Exploring for the Future program with you. First, I'd like to acknowledge the traditional custodians of the country on where we meet today and where this work was undertaken. Just an overview for you today about today's talk. I'm talking about the Australian government's $225 million investment into the resource exploration and discovery sectors. The Exploring for the Future program, or as I like to call it, EFTF, is a halfway through its program. It's an 8-year program. Today I'll be setting the scene, talking about resources in Australia, setting the direction, the government priorities and strategies that we're aligning to, and of course, EFTF, our systems approach, the achievements in the first phase, and the expanded program, which is starting now and will go to 2024. So setting the scene, why are resources in Australia important? I know, you know. Unlocking Australia's mineral, energy and groundwater resources will drive economic growth, job creation and ongoing infrastructure and community development. The minerals, energy and agriculture sectors account for 11.5% of Australia's GDP and contribute to over $300 billion of exports and employ over 500,000 people. This is really important to remember in 2020 and into the future, particularly because we want a COVID recovery and we'll be relying on these sectors. So what's the challenge? Why are we doing Exploring for the Future anyway? What are we trying to address? Well, this graph's a really good graph to show you. Much of Australia's current resource prosperity is based on discoveries and development from several decades ago in geologically well-known and relatively well-explored areas, or what we're looking for is well-known, we think it is, the traditional elements. In fact, over 80% of Australia's current mineral production is derived from mines discovered prior to 1980, largely in areas where resources are relatively close to the surface. So for a world looking to mineral and resources to drive transition to low emission energy sources and high-tech communications and manufacturing, this is a major challenge. Clearly, we need to be doing something differently. Maybe in exploration, maybe in the science questions, maybe in discovery. We need to drive development. We need to find these tier ones. In Australia, the big untapped opportunity lies in these greenfield areas that are underexplored, undercover, or maybe for different elements of minerals in new and interesting areas. The Exploring for the Future program is about extending our geoscience knowledge into these deep dive, really understanding the surface of the lithosphere, what's there, what's driving the mineral systems, what's driving the energy systems. We want to innovate and develop those tools and shine a light into the earth, open up the search space for resources. By developing a better understanding of the regional geology, how it maps into the national geology, we know we can increase confidence to target exploration activities, develop projects, and plan the next development opportunity, that big discovery. But we want to make sure at Geoscience Australia that the new pre-competitive geoscience data and knowledge that we're developing will help you, the explorer, find that next generation of resources. So you might know how this feels. Where is the resource? Where are we looking? How are we looking? What are we looking for? How do we find it? How do we pinpoint it? Are we looking for the right things? What are the keys? Because here in the Baltic Tablelands, it looks pretty flat on the surface. One of those key exploration questions that we're really trying to answer Well, I'm hoping through this talk, you'll see how we're trying to do it with Exploring for the Future. Just to capture some of the strategic direction that we're adhering to, the Australian government has a mandate for the development of its resources sector. This sets the direction of government-funded pre-competitive programs, this one. It also sets out the expectations. It articulates a vision for Australia to have the world's most advanced, innovative and successful resources sector that delivers sustained prosperity and development for all Australians. The Uncover Initiative, another great framework that we've used at GA to great effect. Uncover, these are loosely words from Richard Blewett. Uncover is a key element in the National Minerals Strategy, which shapes the minerals related work of geological surveys across the country, including Geoscience Australia. The high priorities that were identified by industry have played an important role in setting the scope and activities of Exploring for the Future. It's true. The National Mineral Exploration Strategy is a complementary roadmap that outlines, I'm going to just talk about 4 of the key steps. It drives Geoscience Australia to move from just pre-competitive data acquisition to pre-competitive decision support and tools. With this kind of technology, we can open up new search spaces like the potash industry, the new provinces like Julimar, the nickel in WA, and new mines like Gruyere. It harnesses the capacity, we harness the capacity of all our networks, which is why I'm so excited to be talking to you today. How does Team Australia work? How do we collaborate so that we have the best exploration industry on the planet? How do we drive that innovation? How do we work with the geological surveys, industry, uni, Auscope? We also want to protect the environment. GA's approach is to minimise harm in all of our actions in the field. But more than that, we want to collect data that inform on soils, land use, land degradation, provide baseline chemistry of earth materials and water. And of course, supporting communities, and that's in a wide range of things. Right now, it's probably jobs, but by talking to mayors and councillors and farmers, land councils, traditional owners, general public, we want to include those people in the conversation so they understand what the resources industry is about and how we help them. They all have a mobile phone in their pocket, you know. Lastly, GA has a strategy outlining how we're going to work on this kind of problems to 2028, which succinctly states that GA wants to support and stimulate exploration investment, including critical minerals, and open up a new producing province with over $100 billion worth of mineral endowment, with support from state and territorial geological surveys, industry, landholders and traditional owners. Before 2028, we've got to get our skates on. So EFTF, Exploring for the Future, we had this integrated systems approach. And when you look at it, you go, I know that. That looks right. That we all know that. But we're implementing this type of thinking, developing a holistic understanding of the resource potential across mainly minerals, energy and groundwater, which impacts things like the environment and agriculture as well. Scientifically, there are so many connections. For example, a small groundwater sample may contain traces of minerals and hydrocarbons from deep below the surface, and the same tools used to search for mineralization can indicate the presence and quality of groundwater. So we set out to deliver an integrated resource potential assessment, a prospectus, if you like, for Northern Australia, and that was phase 1 of Exploring for the Future. This exploration undercover, as you know, is pretty difficult, and we really did have to think about it a little bit differently. So with this in mind, we've got another slide here. Our way of explaining our systems approach. We adopted this surface to lithosphere scale exploration, a different perspective to survey and identify regions for further higher resolution studies. And the approach includes modern characterization of the surface, the thickness of cover in basins, as well as this deep crustal and lithospheric mantle architecture. So Exploring for the Future, the first 4 years, Wow, we covered a lot of Northern Australia. This first phase of the program was considered world leading, acquiring and delivering public geoscientific data and evidence required to attract future investment in resource exploration and development. Creating a resource prospectus, a framework for Northern Australia, was an enormous undertaking. It's a big country. The Exploring for the Future program has been one of the largest and most complex geoscience programs in the world. And you can't really see all the detail here. You can just see the flavour of the type of work, the geolocation of it, the expansive nature of it. In its first 4 years, 21 collaborative activities worth over $70 million came together and mapped the geology over 300 million square kilometres of Northern Australia, or 26% of Australia's landmass. We are very grateful to the State and Territory Geological Surveys, AUSCOPE and academia for their financial and in-kind contributions, which made EFTF really solid. Now, this slide lists some, not all, some of the amazing achievements of the first phase of the Exploring for the Future program. I'm not going to read all of them, but there are some pretty impressive facts here. For instance, we collected nearly 180,000 line kilometres of airborne electromagnetic data, the largest server of its kind anywhere in the world. And it provided significant new insights into the location of groundwater resources and especially cover thickness for energy and mineral resources. We also greatly improved our understanding of regional geology of the deep crust through the many magnetotelluric, broadband and long period surveys and passive seismic, which is the AusArray deployments. And these data sets are providing unprecedented views of the huge crustal features at depth and their potential connectivity to the shallow surface, where we're predicting there to be relatively high mineral potential. We also completed the deepest stratigraphic well in the Cannock Basin in Western Australia at 2,680.53 metres. Analysis is still being undertaken, but the initial results are really promising. So more than 250 new data sets are freely available from the dedicated online Exploring for the Future data discovery tool. And there are many reports synthesizing and summarizing the data. We're also working up the science, the key results, the new knowledge. We've published those in 63 extended abstracts, so it's easy to read. For downloading, we can send you that link if you're interested. Just come to GA's website. Now, here's a really great example of how we were using these large-scale geophysical data sets. This is an area between Tennant Creek and Mount Isa, where we identified new, completely buried mineral exploration frontier. Using data sets as AusLAMP, the long-period magnetotellurics, seismic velocity, AusArray, magnetics, gravity, and legacy drill holes, a 200-kilometre-long prospective corridor, known as the East Tennant Exploration Fairway, has been identified and mapped. This map shows some of the key components used to recognise this new corridor. AusLAMP, which is the coloured image in the back, contours of the depth to the lithosphere asthenosphere boundary, which shows a major gradient in this area, and large-scale faults, geologically mapped near the surface from magnetics and gravity and the surface. These data sets correspond spatially and suggest the presence of a major lithosphere scale architecture favourable for localising mineral systems and the presence of fertile mantle source regions. So you might be able to see my mouse, and this is the fairway here, this light green fairway in the middle of the picture. So if you thought that was regional, take a look at this work by Carol Charnotta. What's this? Well, it shows that plate thickness controls sediment-hosted deposits. What did you say? All major sediment-hosted base metal deposits we propose and iron oxide copper gold deposits are found within 100 kilometres of the 170 kilometre contour shown here as a wiggly string line. If you can see the green line that wraps around the middle of Australia, this is what we're calling the 170-kilometre contour. The map on the right, which I was just pointing to, shows the mineral potential assessment for these sediment-hosted base metal deposits. It's a heat map and displays where it's most likely to find these deposits. It reduces the search space for these deposits to just 15% of Australia. It highlights frontier exploration opportunities. It also shows where roughly 100 kilometres away from this line is, where those existing deposits lie. But wait, there's more. Here's a global view of that information. This maps the thickness of the tectonic plates, the lithospheric thickness, or the lithosphere-asthenosphere boundary, the LAB, L-A-B, showing the distribution of sediment-hosted base metal deposits, scaled by deposit size and coloured by age. You can see all the major deposits of this type, of this class, are found above changes in plate thickness. There's a paper here in Nature Geoscience that you should follow up. Back to Northern Australia. Here we show some new information about basin-hosted zinc deposits, using the relationship between basin-hosted zinc deposits and the LAB, which was the slide before. There is fundamental control on the distribution of these deposits around the edges of major cratonic blocks. These edges can be mapped using other data sets. So the left image here shows variations in lead isotope, a lead isotope parameter called mu, which indicates the uranium-lead ratio of the upper crust. High values of mu, pink and reddy brown, indicate a more evolved crust, and lower values indicate more juvenile crust. The major zinc deposits are closely associated with the gradient between the more evolved crust to the west and the more juvenile crust on the blue line. This edge is also visible in the upward continued gravity image on the right. Like the mu image, the deposits are closely associated with a gradient between less dense crust to the west and more dense crust to the right. So here we got the blue line here. I'm just using my mouse. The gradient is seen as an upward continued image at levels of 15 kilometres, 20 kilometres, 50 kilometres. It indicates this edge is being mapped through the crust and into the upper mantle. Multiple different data sets pointing to the same thing. It's amazing. Moving across to the expanded Superbasin, we worked with the NTGS and GSQ to better align stratigraphy across the NT Queensland border through well analysis, including geochronology. The key results included identification of a major new large, highly prospective basin, the Carrara Subbasin. We've demonstrated that the boundaries of the Isa Superbasin significantly expand further to the west than we ever thought before. This means a larger aerial extent of the highly prospective Paleozoic units in the Mount Isa province, which host hydrocarbons, as well as the Century lead zinc deposit, Mount Isa, and to the northwest, the MacArthur lead zinc deposit. Skipping over to the west, the Wakali 1 deep stratigraphic well was drilled in the Wakali embayment in the Canning Basin in Western Australia in collaboration with GSWA. The well is located around 70 kilometres west of Telfer and provides stratigraphic control for the geology of the southern Canning Basin. This well was drilled to over 2,500 metres. The analytical results on the petroleum system modelling on the Wakali 1 well have revealed the main potential source rocks are of Ordovician age and have passed through the oil window and are currently within the early gas window. Local hydrocarbon generation, migration and preservation is evidenced by gas and oil tapping within fluid inclusions in the overlying sandstones. More information to follow on this in the next year or two. The pre-competitive work taken in this Tennant Creek to Mount Isa area has been a part of the program, of course, but we cannot believe that we've seen such considerable tenement uptake by industry while the program's still going. We want to thank those companies in particular who acknowledge the Exploring for the Future program or Geoscience Australia in their company announcements. We know it's not always possible, but through this clear link between program activities and your investment, industry investment, we were able to demonstrate the value of the program to the government and secure this 4-year $125 million extension. This map shows you the tenements as of June 2020. However, we've seen more tenements taken up since then. Today, there are 17 companies with new acreage in these key focus areas, and 12 companies have publicly attributed new tenement acquisitions as a part of the Exploring Future, and that number keeps growing. This is during the program. This isn't 10 or 15 years after. This is during the program. It's just amazing. We thank you for your trust in us, and we thank you for keeping an eye on all the data. Our groundwater assessment work is also leading to better outcomes for remote communities in the region between Tennant Creek and Alice Springs. New data is being used to plan new and sustainable water sources for communities and is pointing to the prospect of new water sources for agriculture in the region. We also did a return on investment, an ACIL Allen report of three of the larger Exploring for the Future activities, or about 40% of the program's budget. And they estimated the total potential benefits could be between $446 million and $2.5 billion, with a potential return of investment to the Australian government in taxes and royalties of between $92 million and $632 million per year. That is a pretty good return. That shows that the program has paid for itself already. We expect additional returns to come from the other projects that we didn't do the investigation in. We feel that we've brought all our work together in an integrated package through an online discovery tool, and that tool also has innovative multi-criteria assessment tools. We'll talk about that a bit later, like now. The Economic Fairways tool. The real power of geoscience data comes from combing it with your regional, your local expertise and knowledge. Moving through from just looking at data as numbers or images and being descriptive to being predictive. And this tool is predictive in our characterization of the resource in this particular area in Northern Australia. We hope that this capacity can build other people's concepts and help support their decision making as well. The example in this slide is a heat map showing the modelled mineral potential of nickel and platinum group elements based on a range of expert selected criteria, where the warm colours show higher potential and the cool colours show lower potential. It's a predictive tool. It maps concepts that you can test different concepts and test different information in the tool. You can put your own information in the tool. And we know that this helped lead to the recent Julimar discovery by Chalice Gold in WA. Okay, so what's next? This program continues. The Australian government announced in June an additional $125 million of funding over 4 years to expand the program. And again, the program, we're looking at having this integrated geoscientific understanding for mineral, energy and groundwater potential. We want to create jobs during the program, and we also want to help industry discover things for the long term. It was announced by Minister Pitt, and the program will focus in 2 corridors, the Western Corridor and the Eastern Corridor, and across Southern Australia, making the program more nationwide. Both corridors are highly prospective for minerals, including critical minerals, for energy resources and groundwater. And there is a significant potential for agricultural development as well. These corridors are close to towns and infrastructure that are essential for the development of industry in these regions. The additional funding will extend the program for another 4 years and expand its reach. The two corridors act as a focus. So we're not sticking to those corridors in particular, and we certainly cannot cover the whole corridor with 125 million, even though we'd love to try. So at the moment, we're investigating a couple of regional studies, deep dive studies, and these studies will seek to support economic development, both in resources and agriculture, and support resilience communities. We want to focus our efforts in these cross-jurisdictional frontier areas or poorly understood areas where resource potential might have its, and investigation into resource potential will have its greatest impact. As with the first phase of the program, we're planning acquisition of new pre-competitive data. The regional studies are likely to be similar in scale and design as the Tennant Creek to Mount Isa study, which I highlighted a bit earlier, in that we'll be using magnetotellurics, passive seismic magnetics, gravity, geochemistry, isotopes, that sort of suite of new data acquisition. As well as drilling, we need to understand the stratigraphy. The regional studies will improve our understanding of basin architecture, lithology, basement depth, interbasin relationships, and groundwater energy and mineral resources holistically. We're considering some national studies, and again, these are the Oz suite of data acquisition, Oz AEM, Oz Array, and AusLAMP, again with a focus on the southern part of Australia and those corridors. Both corridors cross some pretty amazing geology, some of the most prospective and not yet fully understood parts of the country when you overlay this map that highlights basins, cratons and provinces. You can see it much more clearly. The existing geology indicates that corridors are highly prospective for minerals, critical minerals, energy resources, groundwater. And the challenge will be to narrow down the regions on where can we actually maximise bang for buck? Where will we do that, those deep dive studies? Because 125 million is a lot, but it won't cover the whole corridor. It's a challenge. And just to end on, remember that LAB map I showed you a few slides ago? Mapping the corridors or some of the corridors in this area will really help us understand the LAB a bit more as well. So on that note, please keep up to date. There's a lot of different ways to pop into GA, virtually and in person. And thank you for your time today, and I look forward to catching up with you soon.
Thanks so much for talking to us today.
I say that the abstracts from Exploring for the Future this year were really good, so more of that.
Yep, I'm going to take notes. It's really important at the moment. We're in this feedback zone, if you like, feedback. We're getting feedback, and I agree. I think the abstracts are amazing. If you haven't seen them, I'll pop the link in the chat there. And I think there was 65, and they're high quality, amazing science, but really easy to read, really relevant.
That's good. They're like well done. So
yeah, it's in the chat for you. Yeah, thank you. No, I think Coral Shanoda drove that, but a lot of our scientists and our collaborators, I really want to emphasize a lot of our collaborators also contributed to those as well.
There's some nice comments coming through. Well, yeah, Encounter Resources mentioned you directly in their quarterly yesterday. And Geoscience Australia is doing a brilliant job for our industry and our nation. It's an excellent presentation.
It does really matter to us that if you can't get the information, if you're working with a company or you know a company and they can't put it in a stock exchange note or a company note, that they contact us. We can keep these things confidential, but if we know that what you're using, how you're using it, and not necessarily all the details of what you found, but it really does help us continue to do this great work. It's a small team really too. I wanted to just talk about the amazing scientists that we have here at GA. I can check with Richard if he's happy to confirm, but it's around 60 very odd. I was going to say 60 odd people, but they're very odd. No, they're awesome. About 60 people in total for the whole energy, groundwater, mineral systems, data analysts right through the web. It's not very many people, which is why we rely on the collaboration of the states, geological states, territory organisations, and our other collaborators I mentioned earlier. See, yeah, look, we really like to do work everywhere. I think I've got a couple of private messages here, and I'm hoping that we can share with you soon exactly what we're doing and the proposals, the projects that will go forward. And we can't go everywhere, but there's some really humdingers. I tell you, it's going to be really exciting the next 4 years. We've got another private message to me. Thank you for the comments. We're not limited to a specific commodity at all. And in fact, in the new Exploring for the Future program, we'll be looking at traps for hydrogen, just something out of the box there. But we look at an area in the most probably integrated way as possible. So instead of going looking for gold, not finding gold, but tripping over a lead deposit, we go and look for everything. Where are the structural controls? Where's the mineralizing fluid? How deep is the cover? And we use all the different techniques to find the mineral system. Do we have some that are our favorites? I'll say yes, but at the moment, critical minerals is something we're going to spend a little bit of extra resources and time on. Some of the team are working with the Canadians and Americans because we're leading the world in that space, and they want to catch up. So that's a good question. The question was just around, do we have some commodities that we are treating preferentially, for want of a better word?
Is there the opportunity to cross-collaborate with the MinEx CRC research?
That's a great question, Ted. And the answer is that some of the regions definitely, we've been looking at the NDI, particularly the NDI regions where they're already drilling. We've got GA people that are working in MinEx CRC. There's a lot of collaboration, and I expect that there'll be a lot of synergies in this space, especially if you're thinking about South. How that will happen, we just want to make sure that we are careful about not looking like we're just repeating what they're doing, but expand and step out that program. And I think we're already talking to the right people about how will that happen. Once we've really firmed up these regions, where will we draw the box? Where will our next TISA region be? That'll be the next step. But with the support of MinEx state and territory surveys, geological surveys, absolutely, there is a lot of opportunity there. We love our MinEx cousins.
Thank you, Marina, so much again for joining. It was really great to have you on.
Thank you.
Thank you, everyone.